All right, this is going to be the first video for Notes 34, and we're going to start with simplifying rational expressions. Rational expressions, folks, are simply fractions. So for part A, the first thing I'm going to look at is, oh, look, I have a fraction. But what I'm going to do is I am going to see if I can factor the numerator. I'm going to see if I can factor the denominator, and the answer is I can factor both. For the numerator, I'm going to factor out a common factor of 5. So that's going to leave me x minus 6. In the denominator, I'm going to do a difference of perfect squares. So split the x, split the 36, make one positive, make one negative. Cool, I have factored everything. Hey, wait a minute. This factor of x minus 6 completely matches that factor of x minus 6. So you know what you get to do? You get to divide them out. So what's left that didn't get divided out is what you have. So 5 over x plus 6. That is your final answer. Now, what you can't do, right, is look at the original problem and say, oh, look, I have an x and I have an x squared. I can cancel it. Like, no, you can't do that. All right, it has to be factors that get canceled, not terms. Okay. So that's problem number 1, part A. Let's slide on over to part B. Well, this looks like just a bucket of fun. So the idea is we're going to factor this numerator, factor that denominator, factor that numerator, factor that denominator, and just see what I can possibly cancel out. So x squared minus 9 is going to be x minus 3 and x plus 3. It's a difference of perfect squares. And then in the denominator, let's see here, factoring that, x, 5 and 3. I'm going to do negative 5, positive 3, and I want to double check that really quickly. Negative 5 times 3 is negative 15, and then negative 5 plus 3 is negative 2. Okay, so that one works. And then we're going to do, grab back times, and I'll put that in there. Let's see, the other numerator, so x squared minus 25, that's going to be x minus 5, x plus 5. And then the last denominator here, let's see, x, 5 and 3. I need a positive 5 and a negative 3 this time. Let me do a quick double check on that. So 5 times negative 3 is negative 15, and 5 minus 3 is positive 2. Okay. And this is where, in the last problem I mentioned, you have to cancel factors, not terms. Unfortunately, you cannot say, oh, x squared cancels out x squared. And, oh, look, x squared, you cannot do that. These are terms that are attached to these other problems or other terms with pluses and minuses. You cannot cancel those. What you can do, and I will go ahead and use, I don't know, dark highlighter here. I'm going to look and see I have a factor in the numerator that's x minus 3. I'm going to look across the bottom and see if I have an equivalent factor, which I do. So x minus 3 will cancel out an x minus 3. So that's gone. Let me actually go back to highlighter here. So that one's gone. That one's gone. Okay. I can do the same thing. So I have an x plus 3. I can cancel out a single x plus 3. So canceling out those two. Let's see what we got left here. Factor of x minus 5, factor of x minus 5. All right, let's make those disappear. And last but not least, I've got x plus 5 can take out a factor of an x plus 5. So I've crossed out everything. So what that means is each one of these, when you cross them out, you would have something. Basically, mathematically, you're talking about x minus 3 divided by x minus 3. When you do those divisions, what's left in every case is the number 1. And so you've got 1 times 1 times 1 times 1 divided by 1 times... This is all just 1 is left over. That's it. Okay? All right. So that's part B. By the way, that does not happen all the time. But oftentimes, you're definitely, with these problems, going to have many things that you can cancel out. All right, part C. Oh, this is going to be fun because it's division, but you don't ever actually divide, okay? What you do in the case of division is you leave your first fraction the same. And yes, I will factor this in a moment, but we're going to change this to multiplication, and we're going to flip over that second fraction. It's multiplying by the reciprocal, right? You never divide fractions, you multiply by the reciprocal. All right, so now that we've turned it into a multiplication problem, I can go ahead and do all the factoring and then see what I can cancel out. So x squared plus 7x plus 6. Let's see, x, 6, 1, everything's positive. Okay, so that one's factored. X squared plus 4x minus 12. So x, 6, 2, positive 6, negative 2, positive 6, negative 2. X squared minus 4 is going to be x plus 2x minus 2. So this is all the kind of factoring we've been doing since the beginning of the year. Let's see, 5 and 1. Let me double check that one. Negative 5 times 1 is negative 5, and then negative 5 plus 1 is negative 4. Okay, it's good. All right, let that all fade away. And let's see, for this one, I'll go with a bright red. What can we cancel? We have a factor of x plus 6 and a factor of x plus 6. I have x plus 1, we'll take out an x plus 1. And then I have x minus 2, we'll take out an x minus 2. Unfortunately, we've got x plus 2 here, right? Hold on a second. There we go. And x minus 5. My Apple Pencil just said, no, I will not work anymore. So what's left is what you write down. So x plus 2 all divided by x minus 5. If you leave them in parentheses, that's fine. You don't need to because those parentheses were used for multiplication purposes and we're not able to actually multiply any of these together anymore. All right, so that is the end of the first video here. I'm kind of pinching in so you can see all the problems. Starting from a very simple one-part fraction, then we had a fraction times a fraction, leading, of course, into what happens when we are dividing these fractions. But all of them start with the idea of can you factor, and then once it's in multiplication form, can you do any kind of cancellation? Please let me know if you have any questions or concerns, and I'll make another video for some more of the problems underneath this.